This is Dr. D. Govardhan, Professor in Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the topic is impact of elastic body, impact and types of impact. Here we consider a body having weight is equal to W, moving with the initial velocity V, initial velocity U, and F1, F2, F3 are the forces which are acting on it. Because of the resultant force which is acting on the body, after traveling a distance of s in time t seconds, it has attained a velocity of v now. Now, according to the Newton's law of second law of motion, if r is representing the resultant force acting on the body in the direction of motions, and m is the mass of the body, then r is equal to, you can write m into a now, where a is the accelerations which with the body is moving, but acceleration is defined as the rate of change of velocity, hence it is equal to dv by dt now. So the modified equation for the r is equal to m is equal to dv by dt, which is equal to, on cross multiplication we got r into dt is equal to m into v now. Since in order to attain final velocity from u to v, it has taken time t, hence the total impact, the product of r into dt is called the impact, and m into dv is called change in momentum now. So in order to get that values now, integrating the equations on both sides regarding the time from 0 to t and the velocity from initial velocity u to v as shown in the figure now. So which is equal to r into dt is equal to, we can write it to mv minus mu, that is the change in velocity. The product of integration of r into dt is called impulsive. The units are Newton's seconds now. So if r is a constant now, from 0 to t, if it is a constant, then product it can be written as now r into t now. That is the impulse is equal to, it is the difference values of final momentum and initial momentum. Conservation of linear momentum. The momentum of a system in a linear direction is always conserved. That means the momentum possessed by the systems remains constant. Or in other words, the momentum possessed by the body before the collision should be equal to the after the collisions now. So it can be obtained now. The resultant force which is acting on the body, it should be equal to 0 only. That means the momentum possessed by the body at initial should be equal to the momentum possessed by at final. That means it should be remains constant, means the resultant force which is acting on the body is 0. Or in other words, the total moment of the systems in a directions before the collisions is equal to the moment of the system after the collisions in that directions. So the law of conservation of momentum in that case now, assume the two bodies are moving here now, having mass m1 and m2, both are moving in the direction of like this shown in figure. Assume just nothing but u1 is representing the initial velocity of the first body and u2 is the initial velocity of the second body. After the collisions, again they are separated with the velocity of v1 and v2 as shown in figure now. That is, before collision, the momentum possessed by the bodies is equal to sum of the momentum possessed by the bodies m1 and m2, which is equal to m1 u1 plus m2 u2. After the collisions, the total momentum possessed by the bodies is equal to m1 v1 plus m2 v2. According to the law of conservation of momentum, the impulse is equal to change in momentum. That means RT is equal to the difference of final momentum minus initial momentum. That means m1 v1 plus m2 v2 minus of m1 u1 plus m2 u2 now. But if the momentum is conserved, that is total momentum possessed by the bodies before the collisions, when it is equal to the momentum possessed by the after the collisions, the resultant force acting on the body should be equal to 0. That means m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 now, where m1 already represented mass of the first body, e1 is representing initial velocity of the first body, v1 is representing final velocity of the first body after the collisions, and m2 u2 v2 are representing corresponding values for the second body. That means the resultant force, if it is equal to 0, already I told the initial momentum possessed by the body should be equal to the final momentum now. Okay, impulsive momentum method now. Here, in indirect method, in some collisions now, the bodies may be just moves in a coordinate place which is having in both the directions x and y, both the body moving. After the collisions, again they move. If they move in x and y directions now, then according to the problem now, the impulse along the x direction should be equal to the change in momentum along the x directions. Similarly, the impulse in y direction is equal to the change in momentum in y directions. Since momentum is a vector quantity, it is a product of mass and velocity. Similarly, impulse is also a vector quantity. It is the product of force as well as the time now. So the momentum, the impulse possessed by the body in x direction is given by the product of force along the x direction multiplied by the time t, that is fx into dt. It should be equal to change in momentum along the x directions. It is equal to m into v2x minus v1x. Here v2x is representing the final velocity of the body, and v1x is representing initial velocity now along the x direction. Similarly, the impulse along the y direction is given by the product of the component of force along the y direction multiplied by the time. It should be equal to the product of mass and change in momentum along the y direction. That is the change in velocity v2y minus v1y now, where fx is equal to impulsive force in x directions, fy is representing the impulsive force in y directions, and v1x, v2x representing initial as well as the final velocity of the body along the x directions, and v1y and v2y representing the initial and final velocity of the body in the y directions. Here f is representing the resultant impulsive force. It is obtained by the integration of fx square plus fy square now. That impact. The properties of the bodies by virtue of which they rebound after the impact is called elasticity. Here I am taking the example of the ball. When it hit on the ground now, it will rebound at a certain height. But when I am taking the stone, when I just impact on the ground with the same force, it will not rebound now. The property of the body by virtue of which it moves great height after rebound, it is called elastic. The body which moves more higher distance is called having more elastic than the body which is having lesser height rebound. The body does not rebound at all after the impact. Generally, it is called inelastic body. The phenomena of collisions. Whenever two bodies collide with each other, the phenomena of collision takes place as follows now. The two bodies are there now. When they are collide with each other now, momentarily they will come to the rest after the collisions. At the same time, these two bodies compress with each other at a maximum extent. Afterwards, because of property of elasticity, they regain their original shape and they are separated and moves with a certain velocity in the directions. The two bodies attempt to regain its original shape due to their elasticity. The process of regaining the original shape is called restitution. The time taken by the two bodies in compression after the instant of collisions is called the time of compressions. Just now I told, just when the two bodies are there now, when they are collide with each other, the maximum they will now compress now. The amount of time required for the two bodies for the compression is called time of compression, and after the collisions momentarily it will come to the rest and regain its original shape. The process of regaining the original shape of the bodies after collision is called restitutions. So the time taken for the restitution is called the time of restitutions. The sum of the two times, that is the time of compression and time of restitution, is called time of collisions. Sometimes it is also called period of collisions. Sometimes it is also called period of impact. Newton's law of collisions of elastic bodies. It states that when the two moving bodies collide with each other, the velocity bears the velocity of separation bears a constant ratio with the velocity of approach. That is, mathematically, if u1 and u2 are representing the velocities of the two bodies before the collisions, and after the collisions, as if they are moving with the velocities of v1 and v2, according to Newton's law of collisions now, here the velocity of approach is the u1 minus u2 and the velocity of separations v2 minus v1. Here according to Newton's law of collisions, the velocity of separations always bears a constant ratio with the velocity of approach. That means v2 minus v1 is equal to e into u1 minus u2 now, where u1 and u2 are representing the initial velocity of the bodies before the collisions, and v2 and v1 is representing the velocity of the bodies after the collisions, and E is called constant proportionality. It is also called coefficient of restitution. Here I am considering two bodies A and B having direct impact as shown in figure now. Let the body A is having mass m1, initial velocity u1, it is moving toward the right hand side along the line directions, and u2 is representing the initial velocity of the first body, and m2 is representing the mass of the second body. Here assume just u1 is greater than u2, so the difference of u1 minus u2 is called velocity of approach. After the collisions, the two bodies compresses at a certain extent. When the two bodies are compressing, the velocity of the two bodies decreases gradually. When the maximum collisions, that compressions taking place, the bodies come momentarily at rest. So the time required for the maximum compression of the bodies while collision is called time of approach. After that, the two bodies regain its original shape, and the process of regaining its original shape is called restitution. In restitution process, after restitution, the two bodies are separated and moves with a velocity of v1 and v2. Here assume just v2 is the greater than the v1 as shown in figure. Now, as per the Newton's law of collision of elastic bodies, the velocity of separations, that is v2 minus v1, is always be a constant with the velocity of approach. That means v2 minus v1 is equal to e into u1 minus u2 now, where e is called constant of proportionality and it is also called coefficient of restitution. Generally, its values lies between 0 and 1 now. If the values of the e, that is the coefficient of restitution, is equal to 0, then the two bodies are said to be inelastic now. If e is equal to 1, the two bodies are said to be perfectly elastic. But for the most of the bodies, the e values lies between 0 to 1. Types of collisions. When the two bodies are collide with each other, then they are said to be have an impact. There are mainly two types of impacts are there. One is a direct impact. The second one is a indirect impact. It is also called oblique impact. Direct collision of two bodies. In that case, the two bodies are moving linear directions before the impact, and after the collision also, if they move in the same line of motions, then the type of collisions is called direct collisions or direct impact. That is, the line of impact of the two colliding bodies is the same as the line of joining the center of these two bodies and passes through the point of contact or point of collision as shown in figure. That is here now. Here C1 and C2 are representing the two centers of the bodies A and B. If the bodies collide in line contact means the line which is passing through the centers C1 and C2 and the point of contact, it should be lies in the same line now. That is, the line of impact of two collide bodies is the line joining the center of these two bodies and passes through the point of contact or point of collisions as shown in figure. That means C1, C2 and as in just a P is representing the point collisions. These 3 points should be lies in the same line. Then the type of collisions is called direct impact or direct collisions. Here M1 is representing mass of the first body. U1 and V1 is representing the initial and final velocity of the first body. Similarly, M2, U2 and V2 representing the corresponding values for the second body. Then according to the Newton's law of collisions now, according to the law of conservation of momentum, the momentum possessed by bodies before the collision should be equal to the momentum possessed by the bodies after the collisions. That means M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. This equation is valid for the two bodies which are having direct impact or direct collisions. That is, the law of conservation of momentum holds good for the two bodies if they are collide in line, or it is also called line impact. The second case, indirect impact of the two bodies. It is also called oblique impact. In this case, let E1 is representing the initial velocity of the first body, here represented as A, and M1 is representing the mass of the first body. Similarly, m2 is representing the mass of the second body, and u2 is representing the initial velocity of the second body, and alpha 1, alpha 2 is representing the inclination of the velocities with the line of impact as shown in figure u1 and u2 for the first body as well as the second body. That after the collisions, let P be representing the point of impact. After the collisions, the first body is moving with the velocity of v1, making an angle of theta 1 with the line of impact, and the second body is moving with the v2, making an angle of theta 2 with the line impact as shown in figure. The components of velocities u1, u2, v1, v2 along the line of impact are shown in figure. Here u1 is representing the velocity of the first body making with the line impact. Here we are resolving this velocity into two components. One is perpendicular to the line of impact, one more is along it now. These two are there. Similarly, the final velocity v1 is again resolved into two components. One is along the line of impact, the second one is perpendicular. For the second body also, u2 is representing the initial velocity of the second body, and alpha 2 is representing its inclinations with the line of impact. When it is resolved into two components now, one is along the line of impact, one more is the perpendicular, and v2 is representing the velocity of the second body after the collisions. Again it is resolved into two components. One is along the impact, one more is along the line of impact, and second one is perpendicular to the line of impact. Okay, the component of velocities which are acting in the line of impact before the collisions are u1 cos alpha 1 for the first body, and the second body u2 cos alpha 2 now. Similarly, the component of velocity perpendicular to the line of impact before the collisions are now v1 sin alpha 1, and the second one is u2 sin alpha 2 now. So after the collisions, the bodies are moving with the velocities v1, v2, making an angle of theta 1 and theta 2 with the line of impact. Hence, the component of force, the component of velocity along the line of impact of first body is given by v1 cos alpha, v1 cos theta 1 along the line of impact, and v1 sin theta 1 perpendicular to the line of impact. Similarly, v2 sin alpha, v2 sin theta 2 is a component of velocity perpendicular to the line of impact, and v2 cos theta 2, it is the velocity of second body in the direction of line of impact. Now, the components of u1, u2, v1, v2 along the line of impact will cause the direct impact. Now, the direct impact means nothing but the line joining from the two centers of the bodies, and the point of contact is called line of impact. These are contributing direct impact, and all the relations of direct impact holds good for these components. That means it holds law of conservation of momentum. That is, the initial momentum possessed to the bodies in the direction of line of impact before the collision should be equal to the total momentum possessed by the bodies after the momentum. So other components are there, that means which are perpendicular to the line of impact, that is u1 sin alpha 1, v1 and u2 sin alpha 2, v1 sin theta 1 and v2 sin theta 2, which are just perpendicular to the line of impact, will not having any impact on the collisions. Hence, the momentum possessed by the bodies just before the collision is also equal to the momentum possessed by the body after the collisions. That means they are not at all involving in the collisions, or their effect perpendicular to the direction of line of impact will not be changed now. Hence, generally these are not considered. We have to consider only the momentum possessed by the bodies in the line of impact only now. So, in this case now, according to the law of conservation of momentum, the momentum possessed the bodies before the collisions in the direction of line of impact is given by m1 u1 cos alpha 1 for the first body, m2 u2 cos alpha 2 is the second body. It should be equal to the m1 v1 cos theta 1 plus m2 v2 cos theta 2. And also the Newton's law of collision of elastic bodies also holds good for this one. That means the velocity of separations always bears a constant ratio with the velocity of approach. That means v2 cos theta 2 is representing final velocity of the second body minus the velocity of the final velocity of the first body. The difference is called the velocity of separations in the direction of line of impact. It bears a constant ratio, that is E, with the velocity of approach, that is u1 cos alpha 1 minus u2 cos alpha 2. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.